Welcome to Mrs. Coates' class. This is algebra, and we're doing section 1-3 on equations. The vocabulary terms that should be in your vocabulary notebook are here, so you can copy them down as you're listening, or listen and learn. We're going to be working with equations. They're math sentences with an equal sign. The example given, 3x equals 12. On an equation, you have a left side and a right side connected by the equal sign. Number 2, an open sentence is any math sentence that has a variable. For example, 3x equals 15. And it's considered open because we don't know what x is and cannot decide if it's true or false until someone tells us. Number 3, domain. Those are all the numbers that can be used to replace the variable. Generally, they're given. The domain is given to you in the set of problems. For example, 3x equals 15. If your domain was a set of even numbers, then there would be no solution because you need the number 5, so that 3 times 5 equals 15. If the domain is the odd numbers, a set of odd numbers, then you do have a solution, and it is 5 because 3 times 5 equals 15. A set is a collection of numbers. For example, the set containing 0, 2, 4, 6 to infinity is an infinite set, and it's the set of even numbers, even integers. Set notation is a special way of indicating a set and what's a member of it. You can translate each part of this structure right here into the following words. X, and then the script E is a member of. The braces, set, and then containing 0, 1, 2, 3, 4, 5. If a problem asks you to give the root, they're asking for the answer to the problem. And if they're asking for the solution set, they're asking for all possible answers or roots. And that could be maybe one answer, none, or an infinite number of solutions. For example, 6x equals 12 has only one number in the solution set, only 2 works. However, if it said 6x is greater than 12, you have an infinite number of solutions because 3 would work. 6 times 3 is greater than 12, 4, 5, and so on. The problems that you're going to be doing in your assignment, I'm going to send you right now to a website that has 3 problems that you will be doing similar to on your assignment. This website here actually has quite a few problems from your algebra book. So the lady will go through the first example, and we'll begin right now.
We're supposed to solve this equation if x is a member of the set 0, 1, 2, 3, 4, 5. So we have this equation, x plus 5 equals 9. We're trying to get x by itself. So the first step, I write the equation down. Now to get rid of this plus 5, I subtract 5 from both sides. That leaves me just x on the left side, since the 5 and the negative 5 cancel each other out. And 9 minus 5 is 4, so x equals 4. Then I go back and I look at the list. I see that 4 is in that set, so since 4 is on the list of possible x's, then our answer is x equals 4. Let me show you an example where our answer is going to come out very differently. Let's say we have the problem x plus 1 equals 100. So I subtract 1 from both sides. I get x on the left side and 99 on the right side. So x should be 99. However, since 99 isn't on the list of things that x is allowed to be, in this situation our answer would be no solution.
A second example.
We're going to solve this equation over the domain 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. The domain means the possible answers, the possible values for x. And our equation is 2a plus 9 equals 17. So the first thing I always do when I'm solving the equation is I copy the equation down. Now, I'm trying to get a by itself, so I need to move this plus 9. To get rid of a plus 9, I subtract 9 from both sides. 17 minus 9 equals 8, and on the left side of the equation, since the 9 and the negative 9 cancel each other out, I'm left with just 2a. Now I've got to get rid of this 2 next to the a. Since the 2 is multiplying, I'll get rid of it by dividing both sides of the equation by 2. 2a divided by 2 is a, and 8 divided by 2 is 4. I look at the domain to see if 4 is there. It is, so our answer is a equals 4.
And a third example.
So we're going to solve this equation over the domain x is from 0 to 9. Now, this equation is a little complicated. Let me point out some things that will make it be actually pretty easy. If we have 2 or 3 things that multiply together to make 0, one of them has to be 0. It's called the zero product property. So in our equation, we have 3 things multiplying together to make 0. 6 minus v, 1 plus v, and v, all multiplying together to make 0. So maybe 6 minus v equals 0. Or 1 plus v could equal 0. Or v could equal 0. If 6 minus v equals 0, v is 6, because obviously 6 minus 6 would make 0. If we try to solve 1 plus v equals 0, I subtract 1 from both sides, and I get v equals negative 1. Of course, if v equals 0, that part's already solved. So we have 3 possible answers: v equals 6, v equals negative 1, and v equals 0. 6 is in the domain, so we can keep v equals 6 as an answer. Negative 1 is not in the domain, so that answer is not allowed. And 0 is in the domain, so that answer is allowed. So we have 2 answers: v equals 6 or v equals 0.
Keep those problems in mind when you do your even exercises. On the vocab check, the basic review will cover subtracting fractions. So just reviewing, we have 4/5 minus 1/5. Since the denominators are the same, you subtract your numerators. So 4 minus 1 is 3/5. Checking to see if there's any common factor. There is not. We are done. The second example, the denominators are different, so we have to find the least common denominator, and the smallest number that 5 and 7 both go into is 35. So renaming the fractions, 7 goes into 35/5. 5 times 6 is 30. 5 goes into 35/7, and 7 times 3 is 21. Subtracting 30 minus 21 gives us 9/35. And again, the two numbers are relatively prime. There's nothing that goes into 9 and 35, so that's our answer. And the last example, again, the denominators are different, so we find the least common denominator, which would be 9. Smallest number 3 and 9 go into. This one already is 9, so we leave it as 4/9. And then the bottom, 3 goes into 9, 3 times 1 is 3. And 4/9 take away 3/9, it gives us 1/9. That concludes the vocabulary. You need to get your book opened, page 11, and have your paper ready for the evens. Make sure your paper is headed math, room number, full name, full date. You skipped a line, you have page 11 written 1 to 38. Paper is folded, and 1 line of work for 1 line of the paper, and please circle answers. So problem number 2 on page 11, we want to solve for x and then see if that number is a member of the domain. So copy the problem down at 6 plus x equals 11, and we want to get rid of the 6 by the x, so we're going to subtract 6 from both sides. To balance it, we have to do it to the other side. And subtracting, we get 6 minus 6 is 0, that goes out, and then 11 minus 6 is 5. So 5 is our solution as long as it's in the domain, and if we go back and check in the directions on page 11, we can see that 5 is a member of the domain. So we circle it. Skip a line. Copy the next equation, x minus 3 equals 1. We want to find out what x is. So we're going to do the opposite of subtracting 3, add 3 to both sides, and we get x equals 4. Checking, 4 is in the domain, so it is a solution. Problem number 6, we have 6 minus x equals 3. Subtract 6 from both sides. We have the opposite of x equals negative 3. So if the opposite of x equals negative 3, then x must equal positive 3. And 3 is in the domain, so it is a solution. Problem number 8, copy the equation down, skip a line. We have 5x equals 10. We want to solve for x. Since we're multiplying by 5, we divide both sides by 5, the opposite operation. The 5's go out, and we have x equals 2. Checking the domain, 2 is in that domain, so it is a solution. Problem number 10, 2x equals 10. Solving for x, we're multiplying by 2, so we want to do the opposite, divide by 2. The 2's cancel out on the left, and 10 divided by 2 is 5. Checking the domain, 5 is a member of the domain. Skip a line, copy number 12 down. 0 equals 4x. I'm going to solve for x, so we're multiplying by 4. We divide both sides by 4. 0 divided by 4 is 0, and the 4's cancel out. So our solution is 0. If it's in the domain, it is, so circle it. Problem number 14, we have x divided by 2 equals 2. I'm going to rewrite it in fraction form. Make sure you use 2 lines for fractions. X over 2 equals 2. To get rid of the denominator, we can multiply by 2 both sides since we're dividing by 2. The 2's cancel out, and we get x equals 4. And again, 4 is in the domain, so it's our solution. Problem number 16. We have 1/3 x equals 1. We want to get rid of the 1/3, so we use its reciprocal, which is 3. Multiply both sides by 3. The 3 and the 1/3 cancel out, leaving us x equals 3. Again, 3 is in the domain, so circle it. It is the solution. Problem 18, we have 9x equals 9. Since we're multiplying by 9, we're going to divide both sides by 9 to solve for x, so we get x equals 1. 1 is a member of the domain, so it is a solution. Skip a line, number 20, we have x times x equals 25. X times x is x squared. So what number times itself equals 25? We're actually taking the square root of 25. We could use a 5, or we could use a negative 5. However, negative 5 is not in the domain, so the only one we can use is 5. Turning the page, the directions say solve each problem over the domain 0, 2, 4, 6, and 8. The problems are in terms of English, so we need to translate in terms of math. So number 22, we have 12 more than a number is 20. You don't have to write that down, but you do have to translate that. So 12 more, that'd be plus, a number, we can choose the variable x, is the equal sign 20. So we want to solve for x, subtract 12 from both sides. That leaves us x equals 8, and 8 is in the domain, so it is a solution. Problem number 24, we have 3 less than a number is 3. Translating that into math. 3 less than a number, remember that's the one time you can't translate left to right as you read. So it has to be x minus 3. equals for the is 3. Let's solve for x, so the opposite of subtracting 3 is adding 3. We add to both sides. That leaves the 3 and negative 3 cancel out, so we have x equals 6. Problem number 26, we have the English sentence, 4 times a number is 6 more than a number. Translating that into a math equation, 4 times a number, letting x stand for a number, we have 4x, is the equal sign. 6 more would be 6 plus a number, that's still the same number, x. We have variables on both sides, so we want to get it on one side. We're going to move the smaller amount to the other side. So we subtract x from both sides. So 4x, take away 1x, leaves us 3x, equals 6. Now we want to get rid of the 3, so we're going to do the opposite, divide by 3. So that gives us x equals 2. And checking the domain, 2 is in the domain, so it is a solution. Number 28, we have 3b minus 4 equals 11. And we're using the domain 0 through 9. So it's a two-step problem. We always undo it, subtraction or addition first. So the opposite is subtracting 4. Add 4 to both sides. So now we have 3b equals 15. We're multiplying by 3, so divide both sides by 3, and the 3's cancel out, so we have b equals 5. And 5 is a member of the domain, so circle it. Skip a line, problem number 30. We have 13 equals 6d minus 5. Two-step problem again, so undo the minus, the subtraction first, so we add 5 to both sides. Those cancel out, and 13 plus 5 equals 18. So now we have 18 equals 6d. We want to get rid of the 6, the opposite of multiplying by 6, divide by 6. So 6 divided by 6, those cancel. 18 divided by 6 is 3. So our solution is 3, and it is in the domain, so circle it. Problem number 32, we have 5 plus 5n equals 50. Again, a two-step problem. We undo the addition first. Subtract 5 from both sides. 5 minus 5 cancel, so we have 5n equals 45. Eliminate the 5 by the variable, so we divide both sides by 5, and we get n equals 9. 9 is in the domain. It is our solution. 34, we have 3w equals w times 3. 3w equals 3w. By the commutative property, we can rewrite that as 3w. Since both sides are identical, any number that you substitute in for w will work. For example, 3 times 0 equals 3 times 0. 3 times 1 equals 3 times 1. So our solution set is the entire domain. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Circle that, and that's our answer. 36, we have y times the quantity 8 minus y equals 0. So using that zero product property, we need to get a 0 on the left side, so y could equal 0. And 8 minus y could equal 0. So what would make that 0 would be 8. So we have two possible answers, 0 and 8, and they're both in the domain, so they both work. Number 38, we have 27 equals 3k times 3k times 3k. If I move the 3's together by the commutative property and associative property and group them, I get 3 times 3 times 3, which is 27. And the k times the k times the k is k cubed. Trying to solve this, if I divide both sides by 27, I get k equals k cubed. Of the numbers 0 through 9, there are only two that when you cube them, equal themselves. 0 equals 0 cubed, and 1 equals 1 cubed. The others do not work. For example, 2 does not equal 2 cubed. Since both 0 and 1 are in the domain, there they are our solutions. That concludes this section. So take your time with the evens and be careful and check your answers in the back. Good luck.